Alright, so here's a problem from section 4. Again, integrating some trigonometric values, and so we need to do some substitution. What would make this nicer is if we broke up the cosine cubed into a cosine squared x times a cosine x. The purpose of doing that would be, we have another name for cosine squared, it's 1 minus sine squared, using that Pythagorean identity. Once we have that, now we could let u equal sine x, so du equals cosine x dx. Right, so there's our du. We can rewrite this now and say I have u to the 6th times 1 minus u squared du. Again, something with just using power rule. U to the 6th minus u to the 8th. And so we're just using a power rule to integrate this one. Again, at the very end, making sure u equals sine x. So that's one of the ideas from section 4. Another one of the ideas is this power reducing, something that we spent some time in 172 doing. If I have something like sine to the 4th x, like, how do I integrate that? So what we're going to do is manipulate it to something that we know. One of the power reducing formulas, it was a sine squared x equals 1 minus cosine of 2x all over 2. So those are the rules, the power reducing rules. Here's for cosine squared. And so that's just a refresher of the rules we had before. So if we have something like this, what we really have is sine squared squared, where sine squared x, using that power reducing formula, is 1 minus cosine 2x over 2. From here we really need to expand out this 1 minus cosine 2x squared, because we're going to end up with another product, and ideally we'd not like to have to integrate a product of two trig functions. So what we're going to do is we have that 1/2 on the bottom, and it was squared, so it'll be a 1/4, and we have 1 minus cosine of 2x squared. So this gives me 1 minus 2 cosine of 2x. Again, those are fine, plus cosine squared of 2x. Again, make sure we get proper notation in there. This we could separate and integrate. This we could separate and integrate. That is our issue. So what we're going to do is use the power reducing formula on it. So now what I'm going to have is 1/4. I have 1 minus 2 cosine of 2x plus 1 plus cosine of double this angle measurement, so I get 4x over 2. And so now we have something that we could actually integrate. All of our cosines are to the first power, so we'd integrate this, we'd integrate this, we'd get rid of the 2 out of our integration symbol, and we'd integrate these 2 individual pieces. But we have something that we can integrate. So those are a couple of the problems from section 4. So there's just one more I want to look at, and it's doing something with a secant. So that is a secant to the 4th x dx. With the secants, it turns out we'll just have a secant. Doing the integration by parts is nice, What we want to make sure we are doing when we're doing one of these secant problems, or even the tangents, I believe, is making our dv a secant squared x. In this case, that means our u would also have to be secant squared x. The derivative, the integration of this term is tangent x. And then the derivative of this one, we could do it like a u squared, so we'd have 2u du. So we'd have 2 secant x. And then the derivative of secant x is secant x tangent x. So now we could rewrite this. Secant to the 4th x dx is equal to, so we have uv minus the integral of v du. So maybe we could take the 2 out, and we could say what I really have here is secant squared x tangent squared x. I believe tangent squared x, that is something that we could manipulate. Let's see what we have. So we have secant to the 4th x equals secant squared x tangent x minus 2 secant squared x times secant squared x minus 1. And so that's, again, one of those Pythagorean identities that tangent squared is equal to secant squared x minus 1, or a manipulation of that. So this is really just, let's see what this is. We have secant x equals secant squared x tangent x minus 2 times the integral of secant to the 4th x, and then minus the integral of secant squared x. Let's get our dx's in. So, secant squared x, I know what that is. Integral of secant squared x, we showed that up here. That's just tangent x. Secant to the 4th x, I don't know that one, but man, that looks familiar. Oh, I have it over here. So what we're going to do is we're going to combine those, secant to the 4th x. So I believe we would have 3 of them. 3 secant to the 4th x. And that would be equal to secant squared tan x. Again, we added 2 of these to the other side. So I actually have a plus, the minus 2 times this one would give me a plus 2. And the integral of secant squared is tangent x. So I have a secant squared x tangent x. Secant squared x tangent x. And then plus 2 tangent x. And I probably have to have a plus c in there. Lastly, since all my integration is on the left-hand side, and I wanted to know what integration of secant to the 4th x is, let's just divide everything. Let's get that plus c in there. Divide both sides by 3. And so now secant to the 4th x, the integration of secant to the 4th x would be secant squared x tangent x plus 2 tangent x plus c, all divided by 3. So these are a couple problems, a few problems from section 4 that might give you an idea of, how to work some of the homework problems when you're reading the text or watching the videos, how to manipulate the equations so we can integrate them. Hope it helps.